wants to get us started? Marie?
Students begin to think about division as they start with a quantity and break it up into equal groups. This first grade class is finding different ways to make 16. One student decides to break up 16 into twos.
2 plus 2 plus 2.
Oh, you know what? You're going to have to talk a little bit slower because I'm going to have trouble recording these as quickly as you're talking. All right. 2
plus 2.
Mm-hmm.
Plus 2.
Mm-hmm.
Plus 2.
Mm-hmm.
Plus 2.
Uh-huh.
Plus 2. Plus 2.
Oh, my goodness.
Plus 2.
How many twos do you have altogether, Jason?
8.
8. Did Jason have enough twos here? Does this really equal 16? Who can help us? Serena?
You could count you can 2, 4, 6, 8 on each one.
Can you show us how you do that? You can come on up here if you want to.
2, 4, 6, 8, 12.
It's okay. Try again. Start.
2, 4, 6, 8, 10, 12, 14, 16.
Fantastic. So Serena counted by twos up, and that helped her to figure out that Jason had the right number. Did anybody think about it in a different way? Jason, since you wrote the problem, how did you think about it?
2 plus 2 is 4.
2 plus 2 is 4.
And 2 plus 2 is 4.
And 2 plus 2 is 4.
2 plus 2 is 4.
And 2 plus 2 is 4.
And another 4.
And another 4. Hey, I noticed something interesting here. What do you notice about this line right there?
It's all 2s.
It's all 2s. What do you notice about that line there?
It's all 2s.
It's all 4s.
Yeah. 4 plus 4 is 8.
4 plus 4 is 8.
4 plus 4 is 8.
And 4. Hey, what do you notice about that line? Emily?
It's 8, and I know what 8 plus 8 is.
What's 8 plus 8 of?
16.
How do you know 8 plus 8 is 16?
Older students are intrigued with counting by larger numbers. It is important that they continue to keep in mind the quantities these numbers represent. Here, students use cubes to model counting by 25s.
25, 50, 75, 100, 125, 200, 150. 25, 50, 75, 100, 275. That's 175. 200. No, there's no 80. 200. That's come by 20s. They come by 25. 200. 225. 250. 275. 300. 325. 350. 375. 400.
Now, is there a way that you can organize those so I can tell at a glance?
Right in
what it
the
is?
100.
Put 200.
100.
200. 100, 200, 300, 400.
Okay.
I do,
Circles?
yeah, circles, and then I put four legs in each one.
Okay, so how many circles did you draw?
3.
Okay, so this is what I saw on Ebony's paper. And Ebony drew 3 circles, and inside each circle she put...
4 legs.
Okay, so why did you decide to draw 3 circles with 4 legs inside of each one?
Because the question says how many legs are on 3 elephants, and then elephants
Elephants have 4 legs.
And elephants have 4 legs. Okay, so can you tell me how did you come up with 12 after you did this? What was your way of figuring out that there were 12 legs in all?
4 times 3 equals 12.
Okay, so when you say 4 times 3, first you start to say 3 times 4?
Yeah.
Does it matter?
No.
So which one do you want me to put down?
4 times 3.
Okay, so 4, and what does the 4 stand for in your number sentence?
4 legs.
4 legs, okay. And what does the 3 stand for in your number sentence?
Circles. No.
Okay, circles. And I think you told me before, what are each of these circles supposed to be?
Legs.
The circles are
No.
legs?
Elephant.
Okay. And you came up with 12 legs altogether. Was there anybody that had a different strategy than Ebony used to figure out the answer to this problem? David?
I know that 4 plus 4 is 8. So that's 2 elephants.
Okay, so you knew that 4 plus 4 equals 8, and you were thinking of the 4 plus 4 as being 2 elephants?
Yes.
Okay.
And then if we add another elephant, it's 12.
Okay, so if you add another elephant, it's 12. So where am I going
It's
to add
12 legs.
Where am I going to add the other elephant? What did you do after you did 4 plus 4 equals 8?
I did 8 plus 4 equals 12.
Okay, so you put 8 and then 4 more legs,
Equals.
and you came up with 12 legs also. Very good. One of the issues that comes up for third graders when they begin to look at multiplication is the fact that when they're multiplying, that they're taking, as opposed to addition where they might be adding 3 apples to 2 apples, and they're dealing with the same thing. And you know, they're dealing with apples, and then the answer is the number of apples they have when they put those things together. With multiplication, they have to keep track of the number of groups and the number of objects in a group. So this is a difficult concept for them, and it's something that that operates differently than addition. I think that both David and Ebony are examples of students who are really playing with this whole idea of what are the different quantities that are represented in multiplication. They both have had to really think about, like in this particular example, for instance, they've had to really think about what number represents the legs and what number represents the number of elephants, and how those two numbers relate to each other, and what the number at the end stands for, that it's not the number of elephants anymore, it's now the total number is the number of legs. I think that this comes up again and again in multiplication, having to hold on to these different quantities.